Assalamu alaikum. Very good morning, students. So, I welcome you all to the lecture series by the Department of Mathematics, the new college. So, today we are going to see a problem based on maxima and minima. This idea of maxima minima comes under the applications of differential calculus. This topic is actually in the curriculum of B.B.A, B.Com.P.A, B.Sc.IT and B.C.A, etc. So, let us see how to solve a problem based on maxima minima. So the first thing is we have given the working rule of it. The first step is to find the dy by dx. Actually, the function will be given as a y is equal to a function of x. So we are going to find the first derivative of that function y. That is why we have given find dy by dx. That is the first step. The second step is to find the second derivative of the function y is equal to f of x. That is going to be d square y by dx square. The third step is the important step where we are going to find the stationary points by equating the obtained dy by dx to equal to 0, where we get points based on x values. So those x values we are going to substitute in the d square y by dx square. That happens to be the fourth step. After that, that is the important step. So we have the condition that if d square y by dx square is strictly greater than 0, the point which we have substituted to obtain this greater than 0 value is going to be the minimum point. It is actually in the opposite direction. So d square y by dx square is greater than 0 means the point we obtained is going to be minimum point. Likewise, if d square y by dx square is less than 0 means the point that we have obtained is going to be the maximum point. So this is the working rule. Let us start with the actual problem. This is one of the important problem which is a repeated problem in your semester question papers. So we are going to deal with this problem. As per the given working rule, the very first step is to find dy by dx. So we have got a function y in x. So we are going to find dy by dx. So here we have the first term of y is going to be 2x cube, where 2 is a constant, and we are going to differentiate x cube with respect to x. That way we get 3 into x square. The next term is we have minus 3 as constant. We are going to differentiate x square with respect to x. There we get 2x. And next thing is we have minus 36 as constant. If we differentiate x with respect to x, we all know that that's going to be equal to 1. And the last term is a constant term. So dy by dx is actually in terms of general terms is going to be rate of change. We are trying to find the rate of change happening by finding the dy by dx. But 10 is a constant number. Constant means another word is not going to be, it is not a variable, it is invariable. So to find the rate of change happening in an invariable is going to be obviously 0. That is why dy by dx, when we calculate for a constant term, is actually 0. So here we are differentiating the constant term 10, so we get 0. So dy by dx is equal to 2 times 3x square, that is 6x square, minus 3 times 2x minus 6x minus 36 plus 0 is not needed. So dy by dx is 6x square minus 6x minus 36. So the first step is over. The second step is we have to find the second derivative, that is d square y by dx square, which is nothing but d by dx of dy by dx. So now we have to differentiate the obtained dy by dx once again with respect to x. So now we get the values as, we already have 6 here, so 6 is a constant. We are going to differentiate x square alone. Differentiating x square we get 2x minus, again we have a constant 6. Differentiating x we get 1. Just the same logic that we have used for positive 10. Differentiating that we got 0. Likewise here the constant term is minus 36. So differentiating that is going to be 0. So the obtained value for d square y by dx square is equal to 6 times 2 into x, that is 12x minus 6. So the first two steps are over. We have found out dy by dx and d square y by dx square. The third step is we have to find the stationary points by equating this dy by dx to 0. Let us see what happens. So the third step is we have to equate dy by dx to 0. That implies our dy by dx is 6x square minus 6x minus 36 to be equated to 0. I find a pattern here. Every term is a multiple of 6, so I can take 6 outside. 6 times of x square minus x minus 6 is equal to 0. This way we get x square minus x minus 6 is equal to 0. I've just taken 6 to the other side, so 0 by 6 is going to be 0. So we have got this function. Now we have to factorize this function and get the values of x. Since we have a function of x square, we will get two values of x. So to factorize this, the product is going to be minus 6 and the addition is going to be minus 1. Product we obtained by the constant term, minus 1 we obtained by the coefficient of x term. So we have to find out two numbers that satisfies. If we product those two, we should get minus 6. If we add those two, we should get minus 1. That way, let me choose minus 3 and plus 2. So if I multiply these two, minus 3 into 2 is minus 6. Minus 3 plus 2 is going to give you minus 1. So these two are the factors. So x minus 3 times x plus 2 is equal to 0. From this we get two values of x, that are x is equal to 3 and x is equal to minus 2. So these are the two values. These values are actually, one of them might be a maximum point, one of them might be a minimum point, but collectively they are called as stationary points. Stationary points is a collection of maximum and minimum points. Okay, now we have got the points. What you have to do is we have to find which point is the maximum point and which point is the minimum point. For that we have to go to the fourth step. Fourth step, actually we have to substitute these values, the obtained values of x, in second derivative, that is d square y by dx square. Let us see what we have as d square y by dx square, that is 12x minus 6. At the place of x, here we have to substitute the obtained value and see if it is less than 0 or greater than 0. That is our next step. So for the fourth step, we know that d square y by dx square is equal to 12x minus 6. Let me check it. Yes. So we have obtained x value is equal to plus 3. So for x value is equal to plus 3, that means we are going to substitute at the place of x the number 3. So d square y by dx square when x is equal to 3 is equal to 12 times of 3 minus 6. So 12 times of 3 is 36 minus 6, which is equal to positive 30, which is strictly greater than 0. So this implies x equals 3 is the, since we have greater than sign, this is going to be the minimum point. So same method let us do for the other value of x. So x is equal to, the other value is minus 2. If you substitute that in d square y by dx square, let us see what happens. D square y by dx square when x is equal to minus 2 is equal to 12 times of minus 2 minus 6. 12 times of minus 2 is minus 24 minus 6. So the value is minus 30, which is strictly less than 0. So this implies x equals minus 2 is the maximum point. So by following the working rule, we have just come up to finding the maximum point and minimum point. But the question is, we have to find the maximum value and minimum value. To obtain that, what you have to do it, we have to substitute the obtained minimum point. Suppose we have to find the minimum value, means we have to substitute the obtained minimum point in the given equation. That is, y is equal to some function of s has been given in the question, right? So at that place of x, we have to substitute this minimum point to get the minimum value. Likewise, you have to substitute the maximum point to get the maximum value. So we know that x equals 3 is the minimum point. So first let us find out what is the minimum value. So the fifth step to find the minimum value. what you got to do is we have to substitute y of 3. So we know that the function y is equal to 2x cube minus 3x square minus 36x plus 10. So this we know. Now at the place of these x's, we have to substitute 3. We are just finding, this is y of x, we are going to find y of 3. So 2 times of 3 cube minus 3 times of 3 squared minus 36 times 3 plus 10. So we know that 2 times of 3 cube value is 9 times 3, that is 27, minus we have 3 into 3 square, that is 3 cube, which is again 27, minus 36 times 3 is 108 plus 10. So this value is 54 minus 27 minus 108 plus 10. So computing this, we get the value to be minus 71. So this value is your minimum value. Likewise, one can find the maximum value by substituting the maximum point. The maximum point, we know that x is equal to minus 2. So at the place of x, we have to replace it with minus 2. So 2 times of minus 2 the whole cube minus 3 into minus 2 the whole square minus 36 into minus 2 plus 10. So we all know 2 cube is 8. So 2 times of minus 8. So minus 3 into plus 4. So it is minus 12. We have minus 36 minus 2, that is plus 72 plus 10. So the value is minus 16 minus 12 plus 72 plus 10. So computing these, we get the value to be 54. So y of minus 2 is equal to 54. This is the maximum value. So by following these procedures, we have just obtained the actual necessary or needed questions. So the values of minimum values of the function and maximum values of the function have been found. So let me just go with the recap here. So we have followed the working rule. First, we have found out the first derivative of the given function, that is dy by dx, and the second step is to find the second derivative, that is d square y by dx square, and the third step is we have to equate the first derivative, that is dy by dx, to 0 to get the values of x. Those values, those collective values, are going to be our stationary points. So the stationary points we have obtained. Using these stationary points by substituting them in d square y by dx square, that is the second derivative, we have to check if either of it are less than 0 or greater than 0. If a d square y by dx square value is less than 0 for a particular stationary point, that point is going to be the maximum point. Likewise, if it is greater than 0, it is going to be the minimum point. Substituting the corresponding maximum and minimum point in the given function, you get the maximum and minimum value. Hope you understood this problem, and please practice well. All the best. Thank you.